Assalamu alaikum class. Today is our 27th lecture in which we will discuss more about the cylindrical coordinates and the transformation of these coordinates into rectangular coordinate system. In continuation of a previous lecture, we have another example. Convert the point 684.5 in Cartesian coordinate system to cylindrical coordinate system. In order to transform into cylindrical coordinate system, we are required to find out the value of r, which can also be represented by the symbol rho, and theta, which can be taken by 5. So and z remains the same, so its value is 4.5. So rho equals to square root of x square plus y square, substituting the values of x and y, and it gives rho equals to 10. Similarly, for the angle r sine theta, arc sine theta, that gives the sine inverse y over r is equals to sine inverse. The value of y is 8. In terms of sine inverse, the formula is changed. It gives y over r. While if we take theta in terms of tan, then it gives tan inverse y over x. So sine inverse 8 over 10 gives 53.1. That is the angle of its rotation. So the equivalent cylindrical coordinates are 10, 53.1, 4.5. We have another example which is also a point in a rectangular coordinate system, and it is given by x equals to 1 by 2 and y is square root 3 by 2, where z equals to 5. So z remains the same in step number 1. For the step 2, in order to find r and the value of theta, so in step 2 we will find out the value of r, which is given by x square plus y square equals to, substituting the values of x and y, it gives 1. That means r square equals to 1. That gives r equals to 1. Now in step 3 we will find out the value of theta, which is given or obtained from the transformation equation tan theta equals to y over x, which is equals to the value of y is square root 3 by 2 and the value of x is 1 by 2. After simplification, we are left with square root 3. So theta is equal to tan inverse square root of 3. The value of tan inverse square root of 3 is equal to pi by 3. Hence, the cylindrical coordinates are 1, pi by 3, 5. In example number 3, we have to find out the equation in cylindrical coordinates of a cone, which is given by x square plus y square equals to z square. So in order to find out the cylindrical coordinates equation in cylindrical coordinates, that means instead of x, y, we must have r theta. Therefore, replacing x square plus y square by r square, because in rectangular coordinate system, as the equation of the given cone is in the rectangular coordinate system, and r is equal to r square is equals to x square plus y square. So substituting the value, we obtain r square equals to z square, which usually give us r equals to plus minus z. After removing after taking the square root on both sides, since z can be any real number, it is enough to write r equals to z. Either it is positive or negative, it can be any real numbers. Thus in cylindrical coordinates, this cone is r equals to z. So this is the equation, required equation, which is written in cylindrical coordinate system. We have another example in which the point is in a rectangular coordinate system and we need to transform it in cylindrical coordinate system. Here x equals to square root 3, y equals to 1, and z equals to 4. Therefore, r equals to square root x square plus y square. That gives r equals to 2. And theta is obtained from tan inverse y over x. That gives tan inverse. Putting the values of y and x, we got the value of theta equals to pi by 6, and z remains same in both coordinate systems, so its value is z equals to 4. Thus the point is 2 pi by 6 4 in cylindrical coordinates. We have another example in cylindrical coordinates. We have to find out an equation in cylindrical coordinates for the ellipsoid, which is defined by x square plus 4y square plus z square equals to 1. So we have to transform this in equation in cylindrical coordinate system. That means we have to write that equation in the form of r theta z. So we know that the value of x square plus y square equals to r square. Substituting that value in the given equation of the ellipsoid. So taking 4 as a common, x square plus y square equals to r square. Substituting in it, we are left with 4r square plus z square equals to 1, which gives z square equals to 1 minus 4r square, which is the required equation in cylindrical coordinate system. These are some exercises for you people, in which question number 1, you have to find the cylindrical coordinates of the points whose rectangular coordinates are, in the A part 2 square root 3, 2 minus 2, and in B part the points in the rectangular coordinates are 16 by 5, 12 by 5, 3. Question number 2, change the following from cylindrical coordinates to rectangular coordinate system. Means you have to do the converse part of it. So you are given with the points in cylindrical coordinates 5, pi by 6, 3, and in the B part you are given with 6, pi by 3 minus 5. Some more problems to practice. In these questions you have to find out the cylindrical coordinates in which the rectangular coordinates are given, and the answer is also given here. So in question number 1, or you can say that in the part 1, the rectangular coordinate is given by 6 square root 3 8, and it's a cylindrical coordinate, which is the answer or the converted point in cylindrical coordinate, which you will obtain after solving the steps which we have discussed in the lecture. So similarly you can do the following exercise to practice that concept. In these problems, you have to convert the cylindrical coordinates into the rectangular coordinates. Again, you are given with the points in the cylindrical coordinates, and you have to find out their corresponding point in the rectangular coordinate system, whose answers are already mentioned here in terms of x, y, z. These are the few links related to the topic for the more understanding of the concept.